In the lesson today, we're going to look at area of composite shapes. So composite shapes, or you might have been in a composite class in primary school. A lot of primary schools do composites. Composite means composed of other things. So a composite would be grade 1, 2 composite, composed of grade 1 students and grade 2 students. Well, it's very similar with composite shapes. They're made up of more than one simple shape. So it might be 2, it might be 3, it might be 4, etc., etc. And they can be found by either adding or subtracting, depending on what you're actually after. So the story so far, we know how to find the area of a rectangle. Its area equals base times the perpendicular height, or length by the width. Then again, with parallelogram, all we do is we multiply to get the area, we multiply the base by the perpendicular height. And the only difference so far that we've seen with the formula is area of a triangle, where it's the base by the perpendicular height and halve it. That's the relationship between a triangle and a rectangle. So the base and the height need to be perpendicular to each other, and don't forget, make sure we're in the same unit when operating on it. Okay, so let's grab the area of the following shapes. Okay, so checking that the unit is the same, which it is. Now, I'm allowed to divide this up whichever way I want. What I'm going to do is convert this into a triangle and a rectangle. The triangle component simply is a 9 by 5, the rectangle component is simply a 9 by 5 rectangle. This part here is a triangle. Now, the height, this part here, runs perpendicular to the base. The height of it is going to be 5. That 5 there matches up with that 5 there. Now, what's the base going to be? Do I know? Well, it's not listed there, but I actually do know what it will be. I know the distance from here to here is 9, so I know that the distance from here to here must also be 9. 12 is 3 more than 9, therefore this distance here must be 3. Right, so we're going to call this shape 1 and we're going to call this shape 2. So we're going to say area of 1 equals the base times the perpendicular height, 5 times 9, which is 45. Area of 2 is the half times the base times the perpendicular height. Base is 3, perpendicular height is 5. Half of 3 times 5. 3 fives are 15, half of 15 is 7.5. Okay, so our total area will be equals 7.5 plus 45, which is equal to 52.5 meters squared. Okay, so all we do with composite shape questions is we simply turn them into shapes that we know how to find areas of and run the calculations. Now this one here looks a little bit tough, like how can I break this up? Here's one triangle, here's a second triangle, here's a big rectangle, lots of measurements there that I need to go and find, but actually the simplest way to do this problem is to actually consider this a full square. So what I'm going to do is find the area of the full square, which I know is 6 by 6. Okay, so area, and I'll call this shape 1. Area of 1 equals 6 by 6, which is 36. Right, now what I'm going to do then is it looks like this I imagine this being cut out. So someone's come along to the square and cut out this particular shape here. So I'm just going to note that this shape is a triangle, has a height of 4 and a base, because its base is the square base, it's going to have a base of 6. So my strategy is going to be to find the area of the thing that's been cut out, which is half times the base times the height, 6 times 4, and that's a half of 24, which is 12. Okay, last time around what we did was added them, because this bit here had been added onto this bit. But what happens in this situation is that this bit here is actually removed from the total area, from the big square. So what we're going to say is total area equals the big square, take away the triangle, and that's going to be 16, 14. Let's check our unit, centimeters squared. Okay, let's have a look at this last one here. So what we've got, it looks like a house. All right, so what I note here is that I've got a triangle. Okay, so let's draw that. Here we go. We've got a triangle, and it looks like the height is 1. So that'll be that height there, which is the same as that height there. And the base looks to be 8 meters long. So we've got 1 meter and 8 meters. Right, now this part here, we've got a rectangle, and I know we've got things removed from it. Okay, but let's just work out the area of the rectangle, which is 8 meters by 2 meters. Okay, and what we'll do is we'll note that we've got area of square, which is 0.5 by 0.5. Now 0.5 is, or can be written a half, and we multiply that by a half, which is a quarter, which makes sense because a half of a half is a quarter. So a quarter is equal to 0.25 as a decimal. All right, let's go ahead and calculate areas of each of these. So we'll call this shape 1, we'll call this shape 2, and we'll call this shape 3. Right, so area equals half of the base times the perpendicular height, which is half of 8 times 1. 8 ones are 8, half of 8 is equal to 4. Right, this one here, we're going to go area equals base times perpendicular height, or 8 times 2, and that's equal to 16. Okay, note that this is area of shape 2, this is area of shape 1. Right, area of shape 3, 0.5 times 0.5. 5 fives are 25, 2 decimal places on that, 0.25, or a half of a half is a quarter. All right, how are we going to find the total area? So total area equals. All right, what I'm going to do is add shape 1 and 2 together, which is 4 plus 16. I'm going to do that first. So add them together. And then what I want to remove is 2 lots of this cutout here, 2 lots of these windows, if you will. So that's 2 lots of the area of one of them, which is 0.25. All right, 14 plus 16 is equal to 20. Take away 2 lots of a quarter, or 2 lots of 0.25 is 0.5. So that's take away 0.5. And 20 take away 0.5 is 19.5 meters squared. Right, so there are the required questions from you today.